GAC Spartans, hope you're G to G today. Hope you've had a great weekend. This is for pre-cal review underneath chapter 3 at this point. Hopefully you have your review out right now. I'm going to get started with some questions here. And as we keep going through, if you have anything that you would like me to go through, please make sure you let me know. But again, I'm going to start on that chapter 3 stuff, and then we'll move and go forward off of that. Once we're done there. All right. So again, if you need to text me, that's fine. You could text me at 770-757-2240, and we'll get it. We'll go from there. All right. All righty. Very good. All right. So I'm going to get started on a couple of these, but while people are texting, and just wanted to kind of touch base on some stuff. First thing that I wanted to mention was anytime we had one, and I'm just making this one up, let's say we had log base 3 of, let's say 2x minus 1 equals y. One thing that we may want to do, or this could be f of x here, one thing that we might want to do in order to graph this is to determine a couple things. First of all, what is our vertical asymptote? Second, what's our domain? And third, is just graphing it, okay? So if we could do those 3 things, man, you're really going to be set on what we're trying to do here. Now notice that this 2x minus 1 is applied to the log. If there was a value, let's say 2 on the outside added, we would subtract that first. But since there's not, what we can do is actually shoot this over by changing it to exponential form, to where we'd have 2x minus 1 equals 3 to the y power. Now a couple things that happen when we do this. One thing that we want to kind of just back up on is anytime that I have something that's on the inside, that will be what my VA is. Now remember, within a vertical asymptote is what you would have within a log form. Whereas within an exponential form, you would have a horizontal. Okay, so we have a horizontal asymptote for exponential. This could be like 2 to the x power, where this is like log base 3 of x. Okay, so again, that's just the difference with what we're trying to look at within both the log form and the exponential form. But within this, coming back, 2x minus 1 is what we could set equal to 0 to solve for what the vertical asymptote is. So when we add 1 and divide by 2, we'll have a vertical asymptote at x equals 1/2. And that's what we'd have for our vertical asymptote. Now, again, traditionally, if it is 1/2, okay, so there's the graph right there. This graph is normally going to approach it on this downward side. Now, if for some reason this is a negative out here, it would go downward, but that would be given within the problem once we solved for it there. So in this given example, we could add 1 and then divide by 2 to where we get 3 to the y power plus 1 all over 2 to get us what our values are when we set it equal to x. Again, remember within a log form, we do it a little different. This time, we actually plug values in for y to make it a little easier. So if I plug in like -1, 0, 1, 2, and so on and so forth, that would give us our correct answer. So 3 to the negative first is 1/3 plus 1 is 4/3. 4/3 divided by 2 would be 2/3, I believe. You could check me on that, but I believe it's 2/3. Plug in 0 to be 1 plus 1 is 2. 2 divided by 2 is 1. Plug in 1, 3 to the first is 3, plus 1 is 4. 4 divided by 2 is 2. So you kind of get a good idea of what's happening to where finally you have 2/3, -1. Go right down here. We'll go 1 in 0 and 2 in 1. So you kind of get a sense of what the graph's going to look like when it approaches that 1/2 mark, x equals 1/2. So within our domain, we got our graph, we got our VA. To find our domain, the furthest left would be 1/2, and the furthest right would be infinity. Both will have parentheses because it's not equal to, but it's approaching. And so that's what our domain would be. Or you could put, I guess, x is greater than 1/2 as well. I would take that as well. But that's how you would solve for the log form of a graph, okay? All right, I am waiting for questions. So if you have some out there, maybe you're out there right now, you could throw them out there. I see that there's 2 viewers out there, which is absolutely awesome. One main thing that you're going to see a lot on when you approach the problems that you're going to see on the test are ones like, if you see like number 1, changing this to exponential form, 3 to the 5x plus 1 equals 5. Okay, and this 1 should be up at the top, my fault. Another one that we'll look at here is, let's do, that's a good one. This one too is 1. Log base 2 of x plus log base 2 of x plus 3 equals 3. So knowing how to kind of work with both of these here. Now, in this first one, and this is actually, I think, number 1 on your review, the one thing we want to do is first try to simplify by changing this to one-to-one property. But the problem is we can't change 3 or 5 into something where it has the same exponent, or same base, I'm sorry, same base. So we can't. So we could change this to log form. So if I were to shoot this over to the right side, what I would have now is log base 3 of 5 on the right side equals 5x plus 1. Now, how can I simplify log base 3 of 5? Well, I could do log of 5 over log of 3, which is, again, we call that the change of base formula. You can do that as long as you have both values. So log of the outside over the log of the inside. Remember, too, that tomorrow we are going to have a calculator section first, and then also have my non-calculator after that on Tuesday. So once I solve for log of 5 over log of 3, I subtract 1, and then I can divide by 5. When I do this, I end up getting 0.093, so approximately 0.093. All right, I'm getting a lot of text real quick. I'm going to check these out real fast before I go to this next one. Oh, yes, with the range, that's a great question. Coming back to that one, remember in a log form, the range is going to be from -infinity to infinity, right? The only thing that is limited within the log is the domain. Now, in an exponential, it's opposite, right? Because this has a horizontal asymptote. The domain is -infinity to infinity, but the domain or the range would be limited based upon my horizontal asymptote. So just check that out. I don't think that's a huge deal, but you will have to know that after graphing it. Okay, once you've graphed it, that's kind of the last thing there. That's a great question on that one. So awesome, Alexis. That's a great question. All right. Also, I know Makai had a question too. We could go over number 12 for sure. Let me hit this one up real quick, just in case, and then we'll rock and roll. All right. Could someone do me a favor? I just saw someone text me too. I had a couple people text me. Would one of y'all just message me a picture of the scatter plot one? I have the review on me, but I don't have my homework. You could just send me a picture on that. That'd be awesome, and we'll go over that as well. I also have 12, 13, and 16 that we'll hit on as well. Those are great questions. In number 10, I think. Number 10 as well. Remember on this one, I'll do this one quick because no one asked about it. But here, remember, in order to simplify this, we've got to combine both of these logs. Well, since they're being added, we can use that rule, which, by the way, is very important for both parts of the test. And what we do now is change it to 1 log. Now, once I get 1 log, I can shoot the base to the other side, take it to the other side, sparks fly like the 4th of July, change it to that exponential form, and now on the left side, I get x squared plus 2x by distributing, and this equals 8. So now I've got x squared, this should be 2x, I'm sorry, x squared plus 2x equals 8. I subtract 8 on either side, so now I've got x squared plus 2x minus 8 equals 0. And what I can do now is do my quadratic formula. And when I do that, you could also check that out on the answer sheet there. But the answer that I got from it was, let me go to it, -3 plus or minus the square root of 41 all over 2. So again, if you had a question on that one, we could go through it a little deeper, but that's the idea of what it would look like going forward. All right. Awesome. Great questions there. I love the questions, the cues, as you say in text language. Fantastic job. Okay. All right. 12, 13, 16, we're going to hit on here, and a scatter plot linear regression one Yeah, let's do that. Let's do that linear regression one. That's a good one. All right. Now, you got to really listen to me because this one is really hard to do on here because it's harder to see. So when I go through it, just kind of give me your attention on that because I think once I go through it once, I think it'll make sense. All right. So on number, go back to JT's there. Perfect. Oh, everyone, by the way, everyone says Q's nowadays. If you're not saying Q's for questions now, you're not Gucci. Okay? You're just not Gucci. All right. All right, let's do this. Could I, instead of doing number 10, that one's important. The one that is really important is, let's say, number 18, okay? Number 18. Now, when you go to your calculator, you need to go to the stat button, all right? So again, just like Dora the Explorer, I want you to yell out what you're supposed to do when I ask questions, all right, at your screen. All right, everyone will understand, okay? When you go to stat, what do? Yes, I hear you through the screen. You're going to go to the edit button, okay? Now, when you go to the edit button, you have two L's, okay? And no, we're not taking L's. That's not what I mean. This is just lists, okay? L1 and L2. Now, on L1, you're going to list all of your X's. Where on L2, you're going to list all of your Y's. So this is step 1, this is step 2, and this is step 3. Now, just in case, just to make sure that everything's good, make sure on this one, the X value should be -3, 0, 3, 6, and 10. And the Y values are 120, 120.2, 80.5, so on and so forth. So when you graph that, you'll go to that. Then what you can do is go to, if you want to see the graph, which again, you'll have to do with me, you'll have to go to second graph and make sure the scatter plot is on, okay? So go to second graph, make sure scatter plot is on, all right? Make sure that first one says on and it has L1 as the X's and L2 as the Y's. Then you can go to the graph button. Now, when you go to the graph button, you probably won't be able to see a whole lot. So you need to make sure that you fit it in the right window. Well, you know that your lowest X value is -3. So maybe your X min should be like -4. And your max should be a little bit greater than 10 and 11, we'll put. Now, for your Y min and Y max, Y min, I'd like for you to put the lowest value, which would be like 50, right? Lower. And then about 130 for your high. And again, that makes all of these values that are up in X and Y be able to fit in that graph, okay? Now, what I'm going to do is I'm going to have you hold on just for a second because I'm actually going to help myself out by doing this as well, okay? I was actually just talking you through here. Let's see here. Dun, 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 dun. Rising up, back on the street. She got fight and ambition. Sorry about that. I apologize. All right, so I just graphed it, and this bad boy looks something like this here. And I know this is way up there, and it depends on your window. But it should look, or it looks something, I think it was actually like right here, something like that. But it looks something like this. Now, the graph, as long as you show it to me, I'm okay with that. The big thing is go to stat. So this is part 2. Okay, this is part 2. And if you have any questions on this, please stop me through your text there. This is second step. Okay. Go to calc, C-A-L-C. Even your calculator speaks in text language. See, calc for calculations. And now I want you to go down to the EXP-REG because what it's asking for is to give a form that's as follows. Okay, they want this form. So if you go to EXP-REG, that's text language for exponential regression. If you press enter after that, I got that, and I'll put it down here. A is approximately 87.26, and B is approximately 0.94. Okay, so my equation would be y equals 87.26 times 0.94 to the x power. That right there is g to g, And that's the answer for my problem from that linear regression. So half of it will be graphing it, showing me the graph, and then half of me also will be showing me the equation that's there. Okay? All right. Are we Gucci? All right, I'm going to give you just a second. If you have questions on it, maybe you have specific questions on that specific one, that's great. If you have a question on maybe your calculator, maybe it's just not working for you, or maybe you have questions on that, you might want to come in tomorrow morning. Make sure that if you have any questions off of that we go through that together. Perfect. All right, so 12, 13, and 16 is what I have right now. Let's do this. And also, if the connection's not working or if something's going down, please let me know. I think it's good because I haven't heard anything from it. But again, I just wanted to make 100% sure there. Okay. Let's go to 12. All right, perfect. Let's go. Let's see here. All right. Let's do ln of x plus 3. And if this isn't right, let me know. But I think this is going to tell us to kind of graph it, right? Let's find the VA. Let's find domain. Maybe graph it a little bit. This is a good one for that. And then we'll go, the other one was ln of e to the third 5. Or 5, it could be 5e to the third. Either way, it'd be kind of the same thing there. So this one is number 12, I believe. And this one is number 13. Now remember, in trying to simplify this, we can't simplify it because the e to the third and 5 are kind of together. So we've got to simplify it in a way where we can expand it and kind of go forward. So since these two are multiplied, we could break those up by using a logarithmic formula there, or one of our rules there. And if they multiply, we could break it up by adding them together. And I'm sorry, this should be ln. I'm sorry. So what we did was we just broke both of them up. Now, since this is an exponent, we could actually shoot this to the front to get 3 ln of e plus ln of 5. Now, ln of e are like kryptonite, right? They're like kryptonite. So where now we're left with 3 plus ln of 5, okay? It's like me and Thomas right there, okay? Kryptonite. So now what we can do is take the ln of 5, and then once we take the ln of 5, we can add 3 to it. Now be careful, it's not ln of 5 plus 3. You have to make sure it's on the outside. So solve for that first, then add 3. I got 4.61, okay? Approximately 4.61. So that right there would be what the value would be when simplified. On this other one, remember that, like I said earlier, whatever's in the parentheses actually ends up affecting my vertical asymptote. So you could say it this way: the horizontal asymptote is affected by the vertical shift, and the exponential, right? An exponential has a horizontal asymptote that is affected by a vertical shift. So that's just the difference there, okay? So there's two differences on that. Now this x plus 3 is going to transform this thing to the left 3 to where my vertical asymptote would be x equals -3 there, okay? So there'd be x equals -3 because the x plus 3 is on the inside of that parenthesis there. Now, once I look at that, I know that it's at -3, and because there's no reflection, this graph, and it might not be perfect to that, but it'll look something like this, to where the domain would be from -3 to infinity, and also the range would be from -infinity to +infinity, all the way from low to high, right? And then my graph, I could graph this, and I don't think it asks to graph it, but if I could, by saying if this is 10 right here, because there's no base, shoot it to the other side where it'd be 10 to the y equals x plus 3. Then I subtract 3 and make a t-chart where I plug values in for y to get out values of x there. And that's how I would do number 13. I'm going to hold off on that one because I know I went through that one quick. So if you still have a question on that, other than screaming for help, you can also ask me too as well. We kind of go off of that as well there. All right. All right. Ooh, this next one's awesome. All right. This is kind of brings back what we were just talking about. All right. All right, let's do this one. Man, this is good stuff right here. All right, so we have our vertical asymptote, our domain. It wants us to also solve for the x-intercept. My word. And graph it. Man, this is a Gucci problem right here. I'll tell you what. You're looking for a problem date right here, you just throw this one out there, man. It doesn't matter who you ask, they'll say yes. All right, so first thing we want to do is first figure out what our VA is. So in this graph, we want to figure out what our VA is. And remember, whatever's on the inside affects where our VA goes. So if we set 3x minus 9 equal to 0, we could actually add 9 and then divide by 3, right? So x is equal to now 3. So we're going to go 1, 2, 3. Boom, 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 shakalaka, to where my vertical would be x equals 3. Now, as we keep going, what I would recommend is the domain and x-intercept. Let's hold off until last, and let's go to our graph. Okay, so let's go step 2 here. So what we're going to do is we're going to get x by itself. So we're going to subtract 2 to get y minus 2 equals negative ln of 3x minus 9. Okay. Now, once I get rid of this negative, which I want to because I don't want a negative there, if I change this, I can as long as I change these other two. So it'd be negative y plus 2. Now, once I get to that point, I have ln of 3x minus 9 right there equals negative y plus 2. Now, if I had this, remember the base is e, right? I could shoot e to the other side to get e to the negative y plus 2 equals 3x minus 9, okay? Now, once I get to this point, I can add 9 and then divide by 3 and go from there. But now that I think about this, I recognize that I don't think the equation or the problem said that we had to graph it. So guess what? We could actually throw that one out. What helps me here is because I know the x-intercept, my big thing is I want to plug 0 in for y, right? The x-intercept, you plug 0 in for y. Well, what I just did help us, because if I did that, I'd have e to the negative 0 plus 2 equals 3x minus 9, which would be the same thing as e to the second. So once I get e to the second, all right, throw that bad boy in there, e to the second, I got like 7.39, like 7.39 approximately equals 3x minus 9. So I'm going to add 9. Add 9, let's see here. And then I'm going to divide by 3. And I got about 5.46. So x is approximately 5.46. And that right there is what I would have for my x-intercept. That means it's got to be on this side somewhere, right? So that means this graph is going to do something. Oh, I'm sorry, not that way. I apologize. It's going to do something like this because of the negative, right? Because that negative y flex over that x-axis. So because it's going to look something like this, my domain, regardless, will end up being 3, okay, to infinity. And my range, because it's a logarithm, my range would be negative infinity to positive infinity. And that's how I would graph it there. But again, as far as a specific graph for this one, at least, you won't have to do it. One that will happen is, again, one like I did over here is one that I could graph, because again, I could shoot that over easy to get 10 to the y equals x plus 3, subtract 3, so 10 to the y minus 3 equals x. And that's where I could plug in my t-chart, plug in values for y, get out values for x, and continue to graph them, okay? Man, y'all have been great, great, great today. Man, I hope this is helpful for you. If you have any more questions, throw them out there. I know that I'm here to help out any of your needs there. I'm here to be of assistance to you. So any way that I can, please let me know. Again, make sure you know how to graph those logs. Make sure you know how to graph those exponentials. You know, remember that something else too. And I'm gonna keep going here. Let's see. If I had something that looked like this, let's say 9 to the x plus 1 power plus 2, where would the vertical asymptote for this be? I'm sorry, the horizontal asymptote. Remember, the horizontal is affected by my vertical shift. So this would actually be y equals 2 is where that vertical would start. Whereas for a log, the actual inside affects what the vertical is. So this would actually be x equals 3 because this is a vertical asymptote where this one would be a horizontal for my exponential. Okay. Now I hear my phone buzzing all over the place. I got people from Sweden texting me, people from Malaysia, people from Kenya, people from all over the place. Okay. People from Georgia. This is good stuff. All right. 17. Ooh, 21 and 17. Wow. This is good stuff. This is good stuff. I feel like we're on Dora the Explorer. This is that good. I mean, really that good. All right. Let's do that one. Yeah, let's do this one. Let's go here. Let's go 21 first, okay? 21 first. I'm not even sure how to do 21. We're just going to go with the flow because we'll make it up as we go, okay? Is that cool? Because I don't really know how to, I don't know how to do this one. All right, let's see. -3 minus e to the x plus 4. Let's see, make sure I've got that right. Perfect. All right, and we have it equal to f of x. It's a function here, and it says please graph it. So let's find a couple things. Let's find domain. Let's find my horizontal. We know it's a horizontal because it's exponential. And let's find our range. Why not? Let's find those three things once I graph it. Well, one thing I know is that within this problem, I have two things occurring. I know that because of the -3, the -3 tells me that I'm going to go down 3. Okay? Where the x plus 4 tells me I'm going to go left 4. Okay, remember opposite is on the inside. This graph's going to transform left 4. And then the negative tells me that what is originally up is going to reflect downward across the x-axis. Now, if you're confused on that, that's okay. Let's create a T-chart to make sure that we've got everything in order. Now, before I do the T-chart, I always like to know that the vertical shift affects the horizontal asymptote. So I know that at this instance, we're going to have a horizontal at -3, okay, because of this right here. So because I'm going down 3, I know I'm right in this wheelhouse here. Then I'm going to come over to my x, and let's plug in a couple. Let's go like -2, -1, 0, and let's plug in 1, okay? Now, if I plug in -2, I get -2 plus 4, which would be 2 still. So it's really e to the second. Now, you will have your calculator for this one. So you'll be able to graph it. So e to the second. Let's make that negative there. Perfect. I got -7.39. Then I'm going to subtract 3 to get -10.4. So yeah, let's say -10.4. Perfect. Let's plug in -1 now. So let's say it's e to the third. Okay, so we got e to the third there. E to the third. Make that negative. And then I'm going to subtract 3 again. I'll get -23 point. And so you see basically that this is going to continue to decrease, right? So as I go, it's going to continue to move down, 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 down. Now, can we put something that's a little closer to here? Let's say -4. If I plug in -4, that'd be e to the 0, which is 1. So -3 minus 1 is -4. So that might be a little bit better. So 3, 4, -4, -4. So we'll have there, and -2 downward. So this thing is literally going to go downward like so. Okay, downward like so. So what would originally go this way now flex downward because of the negative outside of that e. And so that's kind of what it gives me there. So my horizontal asymptote is x equals -3. My domain is -infinity to +infinity. Remember, exponential will always have all reals are -infinity to +infinity for my domain, whereas the log would have it for the same thing for the range. Now the range is low to high, so the lowest would be -infinity, where the high would be -3. And that would be my range there. You could also say y is, we'll say y is less than -3. You could say that one as well, all right? Oh, great question. How can I tell whether looking at a problem if it's logarithmic or whether it's exponential? Well, remember that it's going to be very, very obvious. Well, there's two types of exponentials, right? Okay, let's do this. two types of exponentials. You have e to the x, that's exponential, or 2 to the x. This could be, oh, that's, excuse me, any number. For the logs, there's two values. You have like log of x plus 1, or you have the natural log of, like, let's say x minus 3. But these two are logarithmic, whereas these two are exponential there. Okay, does that make sense? I hope that makes sense. If it doesn't, let me know. But this right here, again, this would have a vertical asymptote, where this would have a horizontal asymptote. What affects the horizontal asymptote is the vertical shift, right? And what affects the vertical asymptote is the horizontal shift. Okay, does that make sense? I hope it does. If it doesn't, text me back something and we'll be good there. Okay, so those are the two different types on that one. All right, number 17 with an exclamation point. Wow, that's pretty good right there. I like that one. Man, I am Gucci on that one. All right, here we go. I'm not sure how to do this one either. We'll kind of make it up as we go. Okay, sound good? All right, I'm joking. If you're out there just listening to me in Sweden, please just keep watching my podcast, and we'll be G to G. Okay, sound good? Be G to G from there. All right, so let's do this. Let's go on this one. Well, let's look at number 1. On number 1, when you looked at that, we changed it to log form to solve for x. But one like this one is important because this one probably will not be on the calculator section. Why, you may ask? Well, I'm glad you asked. Can anybody say it in their computer screen why this one will not be on the calculator section? I'm waiting for you. Your parents may be worried about you yelling at your Mac, but it's really okay. Yell at your Mac there right now, as loud as you can. I can't hear you. Okay, that's better. It's because I can use the one-to-one property to where if I have, let's say, 2 to the third equals 2 to the 5x plus 1, because these are the same bases, I could cancel, giving me 3 equals 5x plus 1. Well, one thing that I can do with this is with 16, I can make 16 have the same base as 2. In fact, 2 to what power is 16? Well, I know 2 to the 4th would be 16. So where now I could cancel, giving me 4 equals 7x minus 5. Okay? Now, once I add 5 and divide by 7, x would then be equal to 9 over 7, and that right there would be my answer. And you could actually plug it back in and make sure you test it. You plug 9/7 back in, you should get the same thing, and that would be 16. Okay? It's a good question on that one. One that was probably very important to address there. Do y'all have any other questions out there? Maybe as you go through, there's some other ones. Here, I'm going to do this. I'm actually going to screen share this here. Hey, what's up? Holla. What's up in the hizzy? You're in my hizzy. Isn't that what you say nowadays? House is hizzy, something like that. All right. Hey, let's do this just real quick. This is the answer sheet. You kind of test it out. It's also on Haiku below this podcast if you're watching it recorded there. If not, then you could absolutely go back. The one area that I think that we're going to have to struggle with, or that we may struggle with, is this x squared over y. That's one area that I feel like we just need to be careful on. Make sure that that square root comes out as a 1/2 there. That's a big deal on that one. Also, condensing and expanding. That's really, really important. Number 7, number 9. Highlight some of those rules on number 8. They're not too tricky, but just be careful on those. The only thing that I would say too is as I go up, remember this value right here with -5. If I were to plug that back in, it actually wouldn't be a value because it would produce a negative log. So this is correct, though I prefer us throw that -5 out if it produces negative when we plug it back in. Number 10 is a little different because there's no variable in the log, so both of those are correct answers. We did that one. We did that one. Right here, remember that -5 here in number 11. With -5, that's a vertical transformation. Remember, since it's exponential, that vertical transformation will push that horizontal asymptote down 5. So the vertical asymptote would be x equals -5. So just be careful on that. You know, as I look through it, I don't see much of it, much more of what we haven't gone over. However, you may have some more questions. So what I'm going to do is I'm going to finish off with one more. And then, unless there's some more questions, I will let you go there, okay? What if we had the ln of the third root of x squared y over, let's say, z to the fifth, okay? Now remember, this root is really what I feel like we may struggle on, because this right here would be the same exact thing. All of that would be to now the 1/3. Now I would then take the 1/3 to the front, now making everything within the ln, once we divvy it out, with the 1/3 on the outside. Now, since these two on the top are multiplied, we can expand them by putting them in the addition rule. So 1/3 ln of x squared plus 1/3 ln of y. And then since this z to the fifth is on the bottom, we could subtract 1/3 ln of z to the fifth. Now, because these two exponents are there, we could shoot them to the front, giving me 2/3 ln of x plus 1/3 ln y minus 5/3 ln z. And really, that's the expanded version there. The only other thing that I would mention to you with the expanding would be, let's say I had something that looks like this. And this is just basic, but I just want to make sure we're good. If there's a negative there and we're trying to condense it down, all that means, that doesn't mean we put two ln's there. No, that's not what that means. If you do that, I will haunt you and your children's children, okay? What that means is that if it's negative, we put it on the bottom. So if it's minus ln of z, we should have ln of x over z. And since this also is subtracted, the y will also be on the bottom as well. So it should be ln of x over z times y. This does not go underneath z, which will go underneath here. It just means that it'll be in the bottom. So this right here is actually our correct answer. Okay. Now I haven't gotten any more text back. I'll wait for another 30 seconds or so. While I'm waiting, make sure that you look at anything there. You could come in tomorrow morning. I'll be there around 7:10. You can come in for any questions you may have. Other than that, I care about you all a lot. Happy studying. And again, if you have questions, please let me know. All homeworks are due tomorrow, and the review sheet will be due on Tuesday. All right. We are Gucci. Have a great day. And great day to be a Spartan. See y'all.